Okay, so thank you. Let me give you a quick introduction about myself. My name is Ashok. Have about 22 years of experience in information technology. Uh, my last 3 years has been extensively in the area of big data and, of course, in business analytics as well. And some of my projects include data cleansing, where I was involved in migrating data from different sources was structured, optimized for business analysis. That was one thing. And also in the migration part of technology stack from Teradata to Hadoop. So that is one of the projects I was involved in. So this project actually brought performance improvements and, more importantly, provided economy on scale. And one other significant project which I want to say was on retailing. I worked on an application that collected aggregated pricing data for different products for various retailing sites and used predominantly R to determine the demand elasticity of various products. So without further ado, I want to jump into this, friends. So let's go over the deck. Here are the objectives, friends. End of the session, you'll be able to know uh, what is data mining at a high level, what is business analytics, what are the stages of analytics, data mining, and all that. And we will also talk about brief introduction about R and what is the overview of machine learning, what is clustering, what is k-means clustering, right? These are some of the things which we will, discuss. Yes, okay, a lot of people can see. Yeah. So I think people who still do not see, please sign out, sign in. That's a quick fix, friends. Yeah, please do that. Yeah. So friends, data mining, right? It's a very, very important thing uh, in the area of business analytics, right? Data mining is very important aspect, right? So in a nutshell, mining means practice. It's just a practice of examining large data set in order to generate information. So we all must have known about the mining aspect. Now, why do we need to call it as mining? We all dig land, right, for minerals, oil, and we even dig for various things, right? Oil, minerals primarily, or even gold sometimes, right? So uh, similarly, we dig the data here, right? We dig the data in order to get insights, right? So that to recognize some patterns, so which are going to be very useful for analytics, right? Once we know the patterns, right, we kind of mine the data in order to get insights from the data. So that's the primary objective here. So I'll just begin with a quick example. You can see the deck. There's so much of information available here. Like, it's a process of finding correlations, patterns, dozens of fields in large data, and it is also finding useful information from the data, devising knowledge out of it for improving future, right? Because any data which is not analyzed, because data has been there, and data, as the big data is growing, right, data is going to be a lot of data that's going to come in to us, right? Unless we know how to mine the data, how to derive the insights, it is as good as it doesn't exist, right? So mining is a very important aspect. So let's talk about some examples, right? For example, I want to say about clickstream data. So whenever you are viewing a public site or visiting any site in the internet, we always leave clickstream trail, right? So that data, we kind of leave it. When you look at the information, you know, just like that, right? It may not really seem useful at an initial glance. However, let's say that you are a retailer, right? If you are a retailer, you're going to analyze the trail of data the users leave, right? So what does a user do before clicking the final purchase button, right? So we get the complete picture of the customers, and we can even we can understand the nature of the customer. We can even profile the customer to an extent, right? So these are some of the benefits. Like, another example could be like in telecom, right? We all know the people, we call them as churners, who kind of defect to a different service provider, right? These people are known as churners. So we can do this analysis, right? It helps us to identify the profitable customers and find out what can be provided as customer retention. How can we retain these customers? Because if any churners, if we can analyze and find out, mine the data and find out people who are on the verge of churning or on the verge of defecting to a different service provider, how can we stop them, right? So, and people do mining the data in the credit card as well, just to study the consumer behavior um, of certain section of people, right? There are myriads of it can be uh, data can be mined and insights can be derived almost in all the domains, right? All the domains today. So bottom line, the transactional data does not bring in much value unless we mine the information and get the insights, right? So data mining is a practice that involves examining a large data set in order to get the insights from the data, right? So there are a lot of techniques in that, clustering, association rules, neural networks. There are lots and lots of techniques available. So let's talk about business analytics here, right? Um, we'll take a quick peek at this. If you look at the definition, right? Any business, for example, business analytics is all about, study of business data using statistical techniques and programming for creating decision support and insights for achieving business goals, right? So any business, it's all about, two essential aspects. One is to increase the revenue, which will positively impact the bottom line, or in other words, the profit, right? Profit of a company. And the other aspect could be like, bringing down the cost. If a company misses revenue targets, they always look various ways to find out, how they can cut down the operational cost, right? So this is a pretty essential thing which any company, follows this. So business analytics is all about, offering support to the organization to arrive at informed decisions backed up by solid data to achieve either to increase the revenue or to cut down the cost, right? So if you look at this study of data through statistical operational analysis and make use of past data statistical methods to understand business performance, makes it necessary steps to improve it. And it is an intersection of business and technology, of course, because it is just not technology, right? So it's about extensive domain knowledge as well. I have a question right now, which I'm seeing from Mithun Raja. What is the difference between, in fact, I was just about to ask this question to this section of audience, difference between business intelligence and business analytics when it comes to decision making. Okay, so that's an excellent question, Mithun. So let me answer this. Um, business analytics, if I need to answer it in one sentence, right? Analytics is futuristic, business intelligence is historical, right? If I want to just say that in a one line answer, right? So BI, which is business intelligence, we have, for example, data warehouse in a company. Using that, we can generate reports, right? We can generate reports and dashboards, but it is not a very futuristic thing, and we don't make any kind of prediction in this, right? And whereas in analytics, we create a model after analyzing the historical data that can predict the future, right? So it's a very forward looking, because it is more a predictive model, something that can lead to futuristic insights, right? So Mithun, am I clear? I mean, are you understanding the difference? Yeah, sure. Thanks. Let's look a little further. Why is it getting popular these days? Okay, friends, can you just throw some insights here? I want to ask you, why is business analytics really catching up now? Why is it, it was, it is creating tremendous buzz around, the circles, right? So why is it all of a sudden? Competition is high. There is one of the answers here. Growing data. Excellent. Data collection, easy now. Excellent. Yeah. Large volume of data. Need for prediction, unstructured data. Excellent. Yeah. Available data. Okay. Excellent. I think I'm getting a lot of great answers. Time to report. Yeah. Make profit. Okay. Unstructured data used to gauge customer needs, desires, big data. Yeah. So I think you guys know. I mean, you guys have summed it up nicely, right? So the in a nutshell, if I want to say this, right? If we have the data, we can start the analytics. As simple as that, right? In a nutshell. So all these are like, strong indications of advancement in analytics and how it is going to play a vital role in making business decisions. So let's see, I mean, as you all rightly pointed out, in the last 2-3 years, the business analytics has really picked up steam, right? It has created tremendous buzz, right? And the reasons are, I think whatever you said, they're all uh, perfect answers, right? Of course, with the advent of social media coming into the mix, right? Social media coming into the mix, lot of unstructured data is coming in, right? And we cannot no longer ignore the social media, because in way back in 2006, if you just rewind your memory, right, if you go back a few steps back and think 2006, people were using Orkut and all that, right? Orkut, probably, Orkut is already dead now. So those days social media is just used as a hangout tool. People just, probably, a person who is working on, or somebody accessing Orkut in a corporate world, that person is regarded as a wastrel, right? Or somebody who is not probably efficient and all that. Now, social media is a integral part of analytics, right? It's integral part of analytics. We talk about sentiment analysis, just to do test marketing and all that. So it's a very vital cog in the area of analytics. And as data is going to grow and grow and grow, we need to have, we need to do analytics very efficiently here, right? Because we all know there is a gold mine hidden underneath it. If it is properly analyzed, you can derive the insights that can change the, uh, a company's dynamics, or some main important product strategy can evolve out of that, right? So it can really take a company towards profitability. A lot of great things are available. So the significant drivers, I would say, I mean, besides all the points what we said, the costing of the cost of storing data has dramatically come down. Way back in, when I'm talking about 25 years back, right? I mean, early 90s, storing 1 terabyte used to cost you like probably, millions of dollars. I think you'll be very surprised now, right? So today, a terabyte of data storage, you just get it in a small, probably you can get it for like, $70, something like that, right? So it's dramatically, the prices have come down. Similarly, the cost of processing data, just imagine in a 95, right? Even a normal 540 540 meg RAM, I'm talking about mid 95, that used to cost like 50 grand INR, right? So today you can do the same thing. A mobile phone, just a 7,000 rupee phone, can do a lot of processing. It's even more powerful than this, right? The cost of processing data, that has also significantly come down. So these are, fundamental influencers for us to, most of the companies, they were little skeptical, like, few years back on their big data investment, or even, business analytics. How do they now today, most of the companies are like forthcoming. They have not only dipped their toe, they want to go deeper, because they know that things are going to be a lot more useful and insightful for the company as such, right? So okay, Um, Moving on, to make a career with BA, there is a question here, for future or not, is best for future. Yeah, I think of course it's going to be a great career. Well, um, I don't want to go there, Vibhuti, but it's going to be a great career even if you want to pursue something in that, because analytics is there to stay for a long time, right? Because the data is going to grow, because we know the big data mix, the velocity at which the data is growing and the volume it contributes to the volume. uh, when the data is there, you will have analytics, right? So definitely it's going to be a very rewarding career in case you want to make investment on that. Okay, and there are few models here. It's called cross industry. This is one of the models of um, data mining. So there are few models like crisp is there, and you have SEMM, one other model is there, and you also have knowledge discovery and data mining. So these models are like just like your software lifecycle model, right? Your waterfall and iterative model. In mining also we have crisp model. you know in this, this is also a kind of iterative process. So at any given time we can go back from any step, even if you have stuck at evaluation, for example, right? Evaluation, you can go back to business understanding all the way to validate further, right? So it's a continuous process. So it's and modeling is one of the things. It's not a one time activity, it is a continuous process, right? um, Mining model, right? Because even after the system is deployed, we always try to do continuous monitoring on the model. pre Friends, I think, can I take these questions towards the end? you know what is the pre-qualification for career? What is the scope for MS intelligence? Yeah, because let's go with this flow. And if you have anything pertaining to this, I would appreciate any questions pertaining to this, right? Who can get this course? Yeah, I mean, a lot of people are asking what is a pre-qualification for getting into analytics, because it's a specialized domain by itself. So um, and again, MS, there are a lot of people who are providing postgraduate courses in that, right? Who can get yeah, anybody who is if you have the aptitude for math and stats, right? It's going to be a great thing. If you have aptitude for math, I would say, not that you need to be a master. If you have aptitude, so you can do this. Where can I take this? No, I don't have an idea about this, Sandeep. I think if you just Google it, a lot of universities are offering, right? Okay, so let's look into R, right? So R is an open source. Okay, it's an open source statistical software. It's also a language. When we download the commands, what we write in R is the language part, right? So R enables us to communicate analytical results in a very innovative, visually appealing way, right? That even the non-technical audiences can clearly understand. So R helps to improve processes and effective, by even the effectiveness, by enabling analysts to conduct analysis efficiently, right? So coming back to this, R is flexible, right? R is flexible. It has all the types, classes, packages, and all that, right? So it has got, as we speak, we have about 5,000 packages in R, right? We have about 5,000 packages, and it is an open source, so that is an added attraction, right? And it is supported by an active community of users and developers. So you've got a very big community following for R, right? Any kind of problem, most of the problems, whatever you might face while using R, if you just go to the community, you have the answer most of the times, right? So this is gaining popularity because there is a lot of advancement in analytics, and R is one of the leaders in this space, right? It was actually, if you go back to the history, right, it was born as S, you know S as in Singapore, right? Then it became S plus, now it is called R. So it has been in existence for nearly 15 years. So it is open source. A lot of vendors, like, we have R Studio is one of the vendors, right? And we have Revolution Analytics. They have come up with their own flavors towards commercial development, but the core platform layer remains the same. This is quite similar to what you see in Linux, right, where we have different distros, but the core platform or the layer is the same, right? So even for 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 your information, even IBM, Teradata, Oracle, SAP, they have come up with their own versions of R. It provides a lot of um, corporate usages ranging from telecom, pharma, financials, life sciences, gaming. I mean, you name it, R is there. It has penetrated pretty deeply into all these things. And again, just want to reiterate the advantages. It's an open source. It provides advanced graphical features, right? It has GUI that helps learning things faster, easier, and it can connect to any kind of databases and data types as well, right? So can even cross-platform. Yes, that's right, Prashant. And our program can pull data from social media. Uh, it provides reuse potential as well. See, if you want to develop a package also, there is a committee. You develop something which can read data from, for example, social media. All you have to do is just develop the package, and then uh, once it is once you get the approval from the panel, then it is set for usage for the others. So let's, I'm just want to take a quick look at the question window. Uh, what is the advantages of R using, SAS? I'll come to that. SAS and R. Sure, I'll come to that. Is a person wants to make career with BA, what language he needs to study? Only R? No, I think Vibhuti, the point is, there is no company which will say R, SAS, because both are here to stay. Just for your information, right? Because and if you know R, because R is got great acceptance in the industry, right? So R is a pretty, if you know R, I think you have a good chance of um, because many companies use R, right? And SAS as well. So I would say, knowing R, because R is slightly, it has an edge over SAS when it comes to the number of companies using overall usage of R in the industry. Definitely R is ahead, right? So we will see that. I'll just mention some comparison. Sure. How is R different from SAS or Hadoop? I would probably make a comparison on SAS, so I'll come to that. What are the limitations of R? I believe it processes data using RAM, so memory limitations are there. That's right, Mariappan. That's there. That's generally there, but that's not a big crunch as well. You can still, it uses memory, so R inherits from C and C++. It was developed using, I would say, Fortran to start with, and even R was used towards the later point, right? So the advantages, as I told you, it is open source, right? Um, Open source provides advanced graphics, and uh, it can connect to many data sources. That is one thing, right? And disadvantages, doesn't have dedicated support for R, right? You don't have dedicated support, and because there is a but there is a strong community available that serves well. Can we install R on cloud? Let us complete. Yeah, sure. That's right. So we will go, friends, shall we take up questions? I do agree with what, let's go with the flow, and let me take up the questions towards, probably, I'll pass for questions. Fine. So we need to know, for example, disadvantages. Stores data in RAM, as one of you pointed out, need to have better programming skills, and we need to know which package to use. There are about 5,000 packages, right? So we need to have a good knowledge on these packages, right? Because we without which you may not be able to use the which package to use where. And let me draw a comparison with or with SaaS, right? um, SaaS is expensive because of annual licenses, but one good thing is it has dedicated support, extensive documentation, which is a gap in R. And we need to have, again, you need to have programming skills and all that, right? So I mean, if someone asks you like, will SaaS there to replace R, the answer is no, right? In fact, you will be surprised. The SaaS Studio, which provides capability to interface with our language, because they are finding ways to make them work better with each other, so that in the best interest of customers. So that's why both of them are here to stay, right? Data analysis software, increase popularity is increased substantially in recent years, and it's uh, R is for statistical analysis. Primary, it makes things pretty simple for the analysis. Look at the characteristics. Effective fast handling storage, a bunch of operators for calculation of arrays, lists, vectors. Data analysis and visualization. In fact, I would say that R's visualization is definitely superior to SAS or any other tool for that matter, right? It has got very rich visualization. Well implemented effective programming language called S, on top of which R is built. A complete range of packages to extend, enrich the functionality of R, right? So, and look at the visualization, right? So we will in fact see as part of visualization. In fact, as I told you, R has got um, advanced graphics, right? So we can have a very good visual representation of data that can be used for effective communication, right, of information with clarity and integrity. And visualization, again, friends, it is one of the most important aspect in analytics, right? If you just go with your p-value and k-means to your senior leadership or executive leadership, right, it's going to be a disaster, because they don't want to know all that. You need to talk the business lingo, right? So you need to have a good visualization technique, right? So R provides all these things. RSS, it provides with it has got great rich visualization capabilities. So you can actually, just to stimulate the viewers engagement, right? There are a lot of functions in R that can do things. Yeah. So who uses R domains, right? This is another if you see this, right, there are lots and lots of industry, as I told you in the beginning, right? They use R. Like for example, in I told you about the churners in the telecom industry, right? So they can, we can analyze the historical data, coming back to the churners context, right? So historical data, and is this, we can actually see, is the trend with, for example, if you find some of the churners, right? If you find some of the churners, right? If you have identified the potential churners who would defect to a different provider, what you can do is, you can do some analysis and see whether the trend is reflecting with a particular age group, or does it happen with certain salary range, or is this an attribute of a particular city, and so on and so forth, right? So once done, we kind of document our findings, make it as a report, right? We share it with the leadership. Then we narrow down, based on what should be the action plan to address this issue. So that's how it is typically done in an organization, right? So we can, even the marketing team or the sales team, they can try to entice them with some offers, or try to find out what was the actual reason for them to think that way. Why do they want to defect, right? So all these things, because why people want to do this is like, customer acquisition, new customer acquisition is 5 times more costlier than retaining existing customers. So all the people, all the companies do this as part of customer retention, right? So this is one thing. And similarly in the retailing, in the good old days, I think you all must have faced this. At least I've faced this numerous times when I used to be in US way back in early 2000s. They used to give bunch of discount coupons if you go to a shop like Best Buy, or if you go to a shop like um, any kind of shop, even Target and all that, right? So they give bunch of discount coupons, and you will. Uh, I've never seen them. I used to straight away trash it. The reason was, it never made sense, because you may be buying products A, B, C, and the discount coupons will have A to Z, right? With so many flavors and so many variants in that, right? So because the information was completely irrelevant, right? So nowadays the retailers have uh, they do they launch product promotion based on customers buying patterns, right? Because analytics plays a very important role here. Discount coupon, what do you get on relevant products, what the customer usually buys, right? So giants like the Publix supermarket, Sears, and they're all making significant strides in the area of retailing. They do extensive analysis of data, have they make a lot of business decisions, right? Great business decisions that is not only help them customer retention, they also help them widening their customer base. So that way they are okay, and even the customers remain happy customers. It's a win-win for both sides, right? So that way, it's a great thing to they most of these retailers are making giant strides in this. And there are lots and lots of examples like sports analytics. You all must be knowing how SAP as a company, right? They helped Germany in winning the World Cup soccer, because they identified some of the critical attributes, and they helped how a player can actually they kind of figured out that if a player has reduced ball possession compared to what they were doing, right? So that helps them to pass the ball pretty quickly, and this way they could penetrate into opponent's defense, right? This was again analytics for you, right? And healthcare, we all know that how it is revolutionizing in the areas of genome sequencing, especially in the cancer research and all that, right? It monitors the health of a heart of a person, right? It can predict, even nowadays, it can even predict cardiac arrest by monitoring the heart regularly and quickly. It can even looking at the heart monitoring, right? It can predict the cardiac arrest. And again, in the BFS domain, you have fraud detection, trade surveillance. All these things are, they automate steps to validate oversights, right? So all these things are there. Lots and lots of examples. Again, in airlines, right? We know. Uh, I can give you this example as well. In the airlines, half a terabyte of data is generated in every Boeing Dreamliner flight for a single leg over Atlantic, right? Just imagine the Airbus 380, which is the largest passenger aircraft, how much of information it would generate with 4 engines, right? So, and we are talking about 100,000 flights a day. And in fact, GE has in fact come up with the aircraft optimization project, right? So they do a lot of research on this, and they do a lot of predictive analytics, right? So this is endless, folks. I don't want to give more examples, but this is, you will find it in all the, we have just listed down like 3 or 4 domains here, but you can, this has got entrenched into any domain here, right? So it's going to play an important role down the line. So coming back to, again, I want to just give a high level overview on the machine learning. Friends, before that, I'm looking at the questions, right? A lot of things, okay. So Vishnu, can you hear me now? Vishnu and others, can you all hear? Because I feel he has pointed out that, he lost the voice. Can you all hear me, friends? Yes. Okay. Friends, there are a lot of things you've asked about, I think I gave you a high level overview of R, right? So many of you have asked, the apt courses and what is the comparison on, R. So of course, R can also work with big data, Hadoop and all that. It can do, right? So can it be installed on, with other programming languages? uh, do I need programming skills? Okay, all this, or you need to know, if you know the number of packages, it's going to be very useful, and you can quickly uh, do a lot of things. And in R is not very complicated. You can still do it, right? So, and R can connect to various data sources, as I told you, right? So I'm not, I'm by looking at the questions, I can see that whatever I've told, I think it covers these questions mostly. R with programming languages, R Java, yeah. It is free, Arvind. It is free, very much, right? Because it's open source, right? So R Studio, everything is like, you can just install it, right? It's a very simple installation. In fact, friends, I will take you through R in a while. So please bear with me on this, right? It is Punus. Yeah. Yes. So, moving on, friends, machine learning, right? I just want to give you a very high level, right? So, in fact, this course from Edureka, it really goes to the depth, right? Of you're going to, in R has lots, and because we have lots of coverage in Edureka course, right? So, machine learning is all about. It's a branch of artificial intelligence, just at a high level. The It basically deals with it concerns the construction and study of systems that can learn from data, right? So it is basically, the emphasis is on, automatic methods. The overall goal is to devise learning algorithms that do the learning automatically without human intervention or assistance, right? So I can give you a few examples of machine learning, right? You have diagnose a patient, you know sufferer of, diagnose and figure out whether the patient is suffering from a disease or not suffering, right? Even customer segmentation, right? Predict how customers will respond to a particular product promotion. Fraud detection. Identify credit card that are fraudulent in nature, right? Credit card transactions. Weather prediction. I mean, machine learning is again penetrating into all these things, right? So set of algorithms comes under machine learnings. Development of computer programs that teach themselves to grow and change when exposed to new data. And you got two flavors in this, right? One is supervised learning and another one is unsupervised. Okay, so supervised is like, given the examples of input and output, it tries to learn the relationship between them. Feedback is supplied explicitly. So it tries to predict the continuous, if it just tried, because there is a training data set that keeps coming. Current level of, I'll come to that, Giridhar. Yeah. So the supervised algorithm builds a model to make predictions of the response values for a new data set, right? Okay. Because here in unsupervised, it is like, it is used for EDA, which is exploratory data analysis. But the main difference between supervised and unsupervised, it's like, here there are no labeled responses here, right? Okay. So the most common unsupervised learning method is cluster analysis. We are anyway going to see that today. Current level of, I think machine learning, Giridhar, just to answer your question, machine learning is really, really going, the patient diagnosis, right? It is not a wish list anymore. It is actually there in US. I think if people have joined from US, I think you can endorse this, right? There are there are uh, there are hospitals, they have started doing this, right? Machines are actually replacing the humans for at least the initial diagnosis and all that, right? So uh, and types of machine learning, if you see this, right? You got the Bayes algorithm, Bayes theorem. You have random forest, decision trees. These are all supervised one. Unsupervised, you have this k-means, right? Which we are going to, see that in detail shortly. And you've got the fuzzy clustering, hierarchical, self-organizing maps, right? So all these things, right? This falls under unsupervised ones. Okay, let me throw this example, right? You have people give you a bunch of photos, right? They give you a bunch of photos with information what is on them, right? And you want to train a model to recognize the new photos. So that is your supervised ones, right? So because you are given a model, right? So the training is on based on the existing ones, right? In the unsupervised ones, there are no inputs given, right? I mean, given the inputs, but there are no outputs. You need to discover groups of similar problems. So no, the example what I'm quoting is the bunch of photos with information what is on them, right? It is given. You train a model to recognize new photos. So this is a supervised learning. Sure, friends? Okay. So moving on, friends. Moving on. How many people are familiar with clustering? Have you all heard about clustering? Clustering. Yes. Okay. Just curious to know. Okay. So clustering means, sure. See, clustering is, dividing at a high level, right? Dividing the wider population into smaller groups, right? That's all it means, clustering, right? So it is a technique of making smaller groups from a wider population. That's what we are trying to say. So what could be the example here? Um, Suppose you have a retail company, right? That has got the entire population, we are talking about different customers, right? So here we want to plan, we want to say, we plan to get to the high value customers and low value customers and all that, right? So that is clustering. You want to classify the list of customers here, right? That's one thing. And similarly, uh, even, it is clustering is used in various aspects, uh, for example, uh, let's take an example which is closer to our heart, right? Because this is something which you all will be familiar. In all the companies, they all do performance evaluation, rating evaluation, which is definitely, it comes in, it is scary. And if something results in a promotion, we are all happy. And most of the times, if that doesn't work out, we are all, it's not a great moment overall in a company. But this is an unavoidable exercise every company gets into, right? Performance rating evaluation, we all must have faced it and must be still facing it, right? So let's assume they give rating 1 to 5, as 1 being the highest and 5 being the lowest, right? Fine. So we try to create clusters of employees of high performers and low performers, right? This is clustering. So why do we need to do this, friends? Good ones from the population, whole population, done to minimize the large data. Okay, lot of uh, insights are coming out, right? From so why do we need to do this? Is like, for example, the high performers, we want to probably reward them, provide more opportunities. This is one thing. Low performers, maybe we want to give them training so that they can improve, or probably lay them off, right? Most of the companies, they follow this strategy. So why wouldn't the companies target individual employees? Why not HR comes up with, why not HR come up with policies for, individuals as against policies for groups? Because, HR always, has policies for, for groups, right? Why not they do it for individuals? Any thoughts again? Excellent. Yeah, Gagan says it is cost effective to deal with a group with same characteristics, right? Yeah, and again, it's another. Praneet says time consuming. Sure. So again, it's a time consuming thing, right? So this this one is like, we are talking about mm, one is the time consuming part, another one is the cost. If we do it for everybody, right, it's going to be an endless exercise. It's not going to be very effective. It may be effective, but it's going to be extremely tedious and complex. Correct. It's going to be expensive as well, right? So generally it's applied on a group or a cluster of employees, right? So rating 1, for example, will get, for example, they'll get 20% hike, right? And similarly rating 2 will get 10% hike. Okay, so let's think about, let's think about some of the retailing giants like Carrefour. So do you think they're going to create strategy for individual stores? What do you think, friends? How do you think they are going to come up with strategies for their stores? Is it going to be for individual stores or even, Walmart? Store groups, yeah, groups. Ideally, they will create a cluster or a group of stores, right? Demographics could be based on cluster, exactly, right? Bottom line, it's for a cluster, right? So these are the stores, for example, they may divide it on, maximum number of sales, lowest sales, again demographics, geographies, create strategies for these groups. That's how it is applied, right? So creating in other words, creating a group for population that are homogeneous in nature, right? Homogeneous in nature. Okay, when we create a cluster for high performers, let me go back to the same example. We group all the people whose rating is 1 or something very similar in nature, right? So when we try to form a cluster of high performers, right, there are certain characteristics that will be, I mean, I would say lot of similar characteristics. You would find them, right? We try to put all the high potential, high performing folks into one cluster, right? So you can have some programs for them, that can even enhance their skills and all that, right? Fine. So that is one thing. Similarly, the low performers, right? You will have lot of distance between uh, the high performers and the low performers. That's how the cluster is going to be formed. So you will not find somebody who is borderline, right? Somebody who is in the border, you will not find this. So that's not a good cluster. So when you can clearly distinguish a high performance cluster versus a low performance cluster, you can have efficient strategies to deal with things here, right? With these groups, right? So um, we may consider, for example, in the high performance, we may consider, what can they do, the people who have done, extraordinary work, extraordinary delivery, and they've demonstrated commitment all the time and all that, right? So you will find this, that's what we try to say, high intra cluster similarity, right? You will find these people, right, intra cluster. So you will have a lot of similarities. And again, low intercluster similarity. So you should have, this and this, right? It should be as far apart as possible, right? Intercluster. Finding natural groups among objects, right? So this is a process by which the objects are classified into number of groups so that they are dissimilar as possible from one group to another group, but very, very similar to to the best possible extent within each group, right? So dissimilar is the intercluster. Okay, the homogeneous nature is the intra-cluster, right? So that is something I want you to understand. So how do we do this in R is what we are going to see this, right? We are going to see. So we will also see what is k-means clustering, right? It's a very powerful technique. Fine. So it is basically an algorithm to go in, it breaks the entire cluster into k different clusters. That's why we call it k-means, right? And we need to specify, for example, how many clusters do we need, and this is nothing but the value of k. Fine. This is what we mean by k-means clustering. So how does the algorithm work? Let me just show you. Just give me a minute. Let me probably show you in Just give me a minute if I can use the paint and show you. Okay. See, you have this, right? And you have this. You have this. And for example, you have, these are all the values you have in the clustering, right? Okay. And you want to form clusters. You want to form two different clusters. The way it will work is like we have this x-axis and y-axis, right? So suppose you want to form three clusters, right? Let's say from this you want to form three clusters. So it'll first thing is it'll pick three random points, right? It may pick three random points. Anything can be a random point, right? For example, this will be picked, maybe this will be picked, and this will be picked, right? It'll pick up three random points, right? If I need to define three clusters forming. Okay, so this is called the seed, right? The center one, right? It is assumed to be the center now, right? So in the first iteration, what will happen is the distance between the data point to the three seeds, right? For example, this one, this one, this one, for example, this may align closer to the center. Fine. It may first, it tries to align closer to the center of whichever data point that is in the proximity, right? Which is the nearest. Okay, it will try to align itself in the first iteration. For example, it may form something like this. Bear with my diagram, folks. What I'm trying to convey is only this. Let's say that let me use some other, just I'll use, let's say this one is there. Okay, and second one, maybe it is formed like this, right? The first one also includes this, for example, right? This is the second one. The third one is this, right? This is how it is formed, right? This is how it is formed. Friends, am I audible? Okay. Am I audible, friends? Yeah. Okay. And subsequently, what happens is, you also, okay, it says it's cracking. Okay, friends, if you have any audio issues, please let me know, or you can sign out, but please bring it to my attention so that, if there is anything at my end, I will quickly try to resolve this. So it will align itself, as I told you, right? Then it goes through iteration. It goes through iteration, right? So what will happen is the rest of the day, it comes closer to the seed every time, right? Every time it comes closer to the seed. Then once you have this, right? Once you have this three clusters, because these three were initially picked, they were actually picked randomly, right? These 3 points. So the center points, the center point of each of these images, right? Each of these things, maybe the next center, maybe this, right? Among this, maybe this is more central, right? This may be the center. Similarly, this may become the center. And again, this may become the center in the new center, right? Okay. Again, we want to, this same alignment exercise will going on. That will keep happening. Okay. So I'm having a question. Can I get a recorded version of this webinar? I think Ujjwal, you should get it. If I remember, you can check with the the people who are organizing it, right? You should have a recording if I'm correct, right? So yeah, good luck, Ujjwal. Yeah, and is my, can I come to that, Giridhar? Yeah, I'll come to that. So the main thing is, we this deck is going to be available. Few people are asking this. What I'm going to say is, again, check with the organizers. Yeah. So again, check with the organizer. I think you should be able to get it. So please check with the organizers for the audio, for the recording, and the this one. the deck. Friends, I think we are almost hitting the clock. What I will do is, I'm briefly explain this, right? So that you have a clearer understanding of k-means, right? Because it's very powerful technique. I want you to understand this. Then I'll show you in the R. So that's what I'm going to do, right? So that's one exercise. Maybe it'll take another 15-20 minutes, Ujjwal. Yeah. So this, it is going to again find the center, right? It's going to find the center, and again this exercise, the things which will try to align itself to the, and so this forms a new pattern, rather new shape or geometry every time when this happens, right? So how long this will continue, right? Again center will be determined, and rearranging of data points will happen. The process will be repeated, right? The process will be repeated um, until movement of data points is frozen, or it becomes very very insignificant, right? So then you don't need to make the, because that means the cluster is complete, right? So k-means clustering aims to partition n observations of k clusters in which each observation belongs to cluster with nearest mean, serving as a prototype of the cluster. So this is nothing but the partitioning of the data space, right? We kind of find out the center, we move them, repeat this 4 or 5 times until there is no movement with centroids, right? So this is how it happens. So let me give you a quick example in R. Let me open. I think people are asking, where can I connect with you? Yeah, friends, I think Edureka, please check with the organizers, right? I think they should be able to provide you all these details, right? Please, thanks. So um, let me open R Studio. Just give me a minute. So I have this. Let I have a simple code, friends. I'll just show you. Then I'll also show you one other example that sums it up. Just give me 1 minute. So I have a file. Look at this, right? Okay, I have a file in which you have workers in a supermarket, right? So this is their performance score. Look at this. This is the performance score. Fine. So we need to find out the k-means, right? Our idea is to find out determine the k-means for this. We need to cluster them. Who are all the high performers and who are all the bad performers, right? So that's the purpose of this. This data set is super simple. If you see this, right, there are certain scores which have been given. Higher the score, they are probably higher performers. So we need to cluster the ones who are bad performers, and that's how we are going to do, right? So I have, I'll just show you. Just give me a minute. Just show you very quickly. Okay, that's all I have. Let me show you this. Okay, this is my comment in R, right? To determine the number of clusters. So I'm loading the file, okay? And if I see view D, right? This is my data set. So this is my data set, right? What you saw just now, we have got it loaded into a data frame in R, right? So I'm going to say, okay, this is my intra cluster. So I'll come to this definitions shortly, right? So if I do for this, I'm trying to see, this helps me, this loop, right? It helps me to find out, because you will always have this question, how many number of clusters I should have, right? That's a question to be asked, because based on the data, you need to have some mechanism to find out what is the optimal number of clusters, right? So I will have this and plotting this as well. Just give me a minute. Plot. So this is actually called elbow curve, friends, right? If you see this, right, this is the number of clusters, and sum of squares. We'll come to these things. So if you see this, it actually, the scores, if you see this, right, it tries to plot this, right. When you see this elbow curve, right, this is actually called elbow curve. After four clusters, there is like, it is still going down, right. Six clusters, maybe six clusters is the right thing, right. It is kind of flattening out. Maybe after eight, it really flattens out. So maybe six, maybe five clusters is very optimal here, right? Five or six clusters. Are you understanding, friends? Are you all understanding so far? Yes. So I can do a k-means. Oh, thanks, Pranit. Yeah. You can actually, this is to determine the number of clusters. There are some other thumb rules as well, but this one is a very efficient way to determine the number of clusters. So I can do a k-means, maybe four clusters here, right, on the score aspect, right. Then if I do a, this, it gives me this information, right. It gives me all this information. Okay. So if you see this, it has got, it has basically divided into four clusters, and the data set has got these values, right? For example, 193.1, right? It has put that in the third cluster. That's what it means, right? That's what the interpretation is. So it has got, that similarly, it has put all these values, if you see this, right? The first cluster, third one is like, 85. The fourth one is like, this is what the high performers, obviously. uh, is my voice audible, friends? Is my voice audible, clear? Okay. Where do you find the high performing uh, folks? In which cluster you will find them? In this, there are four clusters, obviously three, right? You find like 85, right? And in the first cluster, maybe, they need training and all that, right? So this clustering vector actually says, based on the data, to which cluster they belong to, right? So it clearly says that. Okay. And it also gives you the mean value of different clusters, right? Mean value of clusters. And cluster one, you know the this is the third ones, right? The third one obviously is the high performing cluster here, right? So we can clearly determine who belongs to where. Then, we can probably, from this you can go with, a strategy for each of these clusters, right? So you have couple of things. Cluster plot, yes, yes, Harsha, we'll come to that. Okay. You also have things like, the strength of the cluster, right? In this case, this is my strength of the cluster, which is 90%. It can even, suppose I want to go down to, two clusters, right? My strength will come down, because that's not a good effective clustering strategy. But if I make it to six clusters, probably, the strength will be higher, because, it's going to be, the cluster will be even more efficient, because, the towards the six, it really flattens out, right? Maybe six is even more, it may give a higher strength, if we can make it, right? Just want to show you this. Six, you find 96.7 percentage, right? This is my cluster strength, right? So just, and these things, right, there are a couple of terms which I want you to understand as well, between SS and total SS, right? It is the distance between center point of two different clusters. This one, right, between SS, distance across the clusters, right, basically. And there is another thing called within SS, right? Within SS is average distance of data points of a cluster, okay, which is this intra cluster. Now tell me, I have a question. Should the between SS be high or low in a good cluster? The between SS, should it be high or low? It has to be high. Yeah. Thanks, Harsha. Yeah, it has to be high, right? And how about within SS in a good cluster? It'll be low. Correct. No, it'll be low, right? Because The within SS is, data points within a cluster, right? Of a cluster, so it has to be very low, as low as possible, right? So the strength of the cluster, we saw this, right? So there are, these some of these terms, but more important ones are these things, right? Between SS and within SS. So that is something intra-cluster similarity and inter-cluster, right? So you can also plot the k-means cluster. So I'll come to that. Just give me a minute if I can plot this. More than one dimension. Ashutosh, I'll come to that. I'll give one other example, friends, and that will be the end. If I can say plot um, the score. Give me a minute. See, look at this, right? Can you all figure this out? See, this is my plotting, right? So you will find the green ones, and you find uh, the black ones are at the bottom, right? The clusters, the based on the scores, right? The top ones are like, it's reflected in a different color, and this is another cluster. And we actually made this to 6 clusters, right? So you are finding 6 clusters, 6 different colors are there. No, x-axis is, here based on the score, we are trying to plot it, Harsha, here, right? You can run it for 4 clusters. Let me do that here. Just give me a minute. Let me zoom this and see how it is clustered now. 1, 2, 3, 4. There are 4 clusters here. Number of people in the distribution, Harsha, right? Number of people, and based on the score, how they are clustered here, right? That's what we are trying to say here. Okay, sure. Okay, uh, friends, I think I'll briefly go through the deck. How the k-means. I think I have already shown you in a very crude way using the paint, which I thought was more intuitive. But you need to know, how this iteration takes place. Then I'll show you a two-dimensional, uh, clustering as well, right? So as similar as possible, should be much difference. Yeah, and let's look at, again how it works. Randomly, the initial points, as I told you, then it starts iterations. No more cluster size remains constant, right? Until it's no more changes, right? It keeps repeating, and every time there's a new. Again, look at this example. There are like marks of 17 students in a class. Group the students, good, average, bad. This is another example, right? So how it works randomly is like, it takes 3 initial centers, right? It makes it as 3, 2, 1, right? It tries to put all these three, right? I mean, it tries to put everything here first, and it tries to put the 2 in this one, the second, third. It has got the third center, right? It tries to put the 1 here. This is the first iteration. Then if you look at it, number of items is 14 here, right? Based on the way we have done this, right? Number of this is 14, this is 2, this is 1. So the distance keeps moving. As I told you, the center keeps shifting every time, right? So again, the sum of items is like 129. Again, the mean is taken. Then now, earlier it was 3, now it has become 9, so there is a change. And similarly here, again, it is, it remains, in this case it remains 2. And the bad cluster, the bad, The average one remains 2 and the bad also remains 1 here. Then the centroid, look at the centroid, right? Fine. So going back to the second iteration, right? Because we need to keep repeating until all the clusters, right? I mean, all the centers, they don't have any movement or the movement is very, very insignificant, right? That's how we stop it. That's when we stop it. Again, um, again we do this based on the centroid 9 and how many we are doing? 12 here, 4 here, 1 here, right? We keep doing this. We keep doing this. Again, the sum of items of these 12 items is 120. There is a shift in the overall mean, right? Again, the center, the centroid is 10 here, right? 120 divided by 12. And again, we keep 3. Here in this case, it's 3 and bad is 1. There is a change detected, whereas there is no change in the bad cluster, right? The bad one. Again, in the iteration 3, look at this. Based on the centroid 10, it has got like 10 points shift to this cluster, 6 points shift to this cluster. The one remains same here, and again there is a change detected in the third iteration. And if you see this again, here it becomes 9, here it becomes 5, and there is a shift of centroid here. If you see this, right? Change detector, and here there is no change, so this cluster is more or less formed, right? Now again we do the next iteration, and no change detected, no change, and there is a small change detected in the good cluster, right? So iteration 6, it kind of settles, right? So we know that 6 is probably the right number. So there is a question on how to control the number of iterations. Okay, control, this is what we give, right, Ashutosh? We give the number of iterations. I can just have 2 clusters also. This is what we give, 4. And how do we say 4 or 6? Based on the elbow curve, what we saw, right? Because we are clearly seeing it is kind of settling down, right? We saw the elbow curve in the previous the graph. So that will determine how many clusters we can have, right? So if you have 4 or 6 or whatever, right? I mean, something that is meaningful, that elbow curve will determine that. Then we accordingly we give the number of clusters. If I want to give 2, right, my clustering strength will really come down, right? If I say 2, and if I you know uh, just k-means, right, look at this, 66%, my cluster, it's not a good cluster at all, right? Yeah, sure. Okay, friends, we'll see one other example before we can before I can just go to the questions. I'll show you the example with more than, it's more than a more than a dimension, right? More than one dimension. So let me go and load this for you. So this is a used car example, and I'll quickly execute this, and I have this data set which is my Toyota Corolla, right? Used car. It has got lot of details like this, right? It has got price range and all this, right? All these things. Okay, just give me a minute. uh, Used car, and I'm taking the kilometer and the price, right? Based on the kilometer we are trying to and the price, right? So just give me a minute. No CSV, just give me a minute, 1 second. Oops. So let me just change it. Just give me a minute, friends. Mm. Bear with me. Just give me 1 second. The path is wrong. You need to give forward slash, friends. That's the only thing. Okay, here you go. Yeah, it's done. And I have the cluster data, and it has got like 1436 observations, and I've got only two variables, right? Two variables, which is kilometer and price. This is what we are trying to check it out. And the head will give you the first 6 rows of data, right? This is the number of kilometers, this is the price, right? Number of kilometers, price, and this will give you the structure. str will give you the structure, right? It gives you the the values. And then we want to repeat the same thing. What is the optimal number of clusters here, right? And let's see the elbow curve here, right? So we are trying to see, I mean, we approximately give 15 here, right? And we are trying to see what is the best cluster here. So how many cluster do you think is the optimal here in this case, friends? In this, looking at this elbow curve, can you just tell me? Yeah, 6 is optimal, right? Correct. 5, 6, yeah, correct. Because it's kind of flattening out, right? So from this, you can clearly determine that the elbow curve is flattening out. So let's go with, we are saying cluster data 3. So let's see what it has to say. Okay, these are all the ones. Okay, uh, okay, you can actually view all these things, whatever I showed you earlier, right? Between SS, one by one you can view. So let's plot this out. Let's plot. I mean, what I want to emphasize here is like, R comes with great visualization, right? We can plot it with this colors, right? You can plot this based on the kilometers. What is the price, right? You can see it comes up with a pretty attractive graph with a cluster, right? Number of kilometers, and what is the price range for these things, right? You can kind of cluster it this way. And you can also do uh, there are, friends, see what I showed you in the initial ones, right? It's a k-means clustering, right? And I gave a very very simple plot, what I showed you, right? But in R, the good thing is, it comes with great visualization. There are various ways to actually uh, cluster information. I mean, various ways to interpret the data, right? Using different um, visualization techniques, right? And you can use different packages just to show, what are all the, different ways to do it in R that's possible, right? So there we will see a few other examples, like few other ways how we can uh, so let me see, just give me a minute, just look at this, right? Few other ways. This is one other way, right? One other way we can do this, because there are different packages, and you even have animation as well. This is the best part, right? This is, you know uh, you can take animation and look at this, right? I'm going to animate for number three clusters, and see how it is settling down. The centers are getting shifted. See how it is settling down. You see this, right? It's beautiful in R. Just see this for a second. Okay, so if I make it like, for example, 6, right? You can have 6. uh, Again, you can, it makes it into 6 different clusters. So again, it'll try to make it like, how many see how it is. The center keeps shifting, friends. I want you to pay attention to this, right? The center keeps shifting here. all these things, right? So the animation is like, pretty rich out here. See, I mean, do you find this interesting, friends? The animation aspect, right? It's pretty cool that this way. And there are, what I've shown you is just a sample. There are various ways to, do this, right? Various ways to do this. There are different packages, right? You can do, and you can even have the what to say structure. You can look at the quality of the cluster by, you know by looking at the structure, and you can determine the quality of the structure, quality of the cluster, overall cluster, right? So any kind of, you know the quality can be determined, as I said, it is through the elbow curve, right, which makes it easy for us to determine the quality. So friends, I think I will answer one, maybe we can open it up for questions now. So we have come to the end. Otherwise, we have seen the animation, so this is what I wanted to show you. So we can look at the uh, probably the questions. So one thing I'm seeing is, what is subspace clusters, right? Subspace clustering. I mean, just a short answer, Giridhar, because it's a uh, it is a it is an extension to your traditional cluster. That's what I would say. It's based on the search strategy and all that, right? It's finding, in a multi-subspace representation, what the collection of points, right? It's something which is beyond your traditional clusters. That is your subspace, and it is especially, it is used in uh, trying to find out all various clusters in different subspaces. That's what is the actual thing. So we use it for, for example, image segmentation, and that could be one of the examples here, Giridhar. Image segmentation is one of the examples of subspace. Can we do OR programming in Mac? Yes, Vishwatosh, it's possible. Yes, we have. We have installations for OR for Mac. Can we? How do we learn writing coding source code? You saw that, right, Krishna? Krishna is asking this. It's pretty simple. I mean, the more important thing is, you need to know what package to use where and all that, right? There are different packages in R. So overall, if you know different packages, right, in R, I think you can start uh, you know and basic programming constructs. If you're familiar with that, you should be good, right? Basic programming constructs and all that, right? If you're fairly familiar with those things, those aspects, you're good. Can we use R for scripting purpose in data handling? Absolutely, yes, Giridhar, because it connects to anything and everything. It can connect to a SAS dataset. It can connect to SPSS. It can connect to SQL, MySQL. It can connect to any kind of database, right? Any kind of data. Simplex clustering. I mean, maybe you can tell me what is a simplex. I'm not sure about that, Vishwatosh, but clustering is, is just a classification of, creating some groups, so that it's just a classification strategy, Vikash. I mean, Vishwatosh. It is a concept of linear programming. Oh, linear programming, linear. Okay. I mean, I told you the clustering definition, right? You just try to classify groups. What are the other languages other than R for BA? You have SAS, you have SPSS, but R is like wildly popular, Giridhar, right? Can we save output results somewhere in database using R? Yes, possible, Ravi. Any known course on different visualization packages? Any known course? Uh, in fact, Srihara, I mean, if you want to, I would say, if you know the packages, right? I mean, the Edureka provides a course, but even otherwise, if you go to Google, there is information about all the packages, right? You can probably take a quick view of what is what and in all that, right? So that you can use it, for just to get a glimpse on different packages in R. Sure. How does R connect to Hadoop? Yeah, we have means, Balaji. It can connect to Hadoop. It can talk to HDFS. Yes, it can talk. How do we plot the sum of square? Why do we plot? Sum of square, something, sometimes it can be negative, right? So we always try to take the sum of squares, Saumadip. Do we need to have any programming stats background to attend the course, Banu Kiran? No. See, friends, you need to have the inclination more than, the experience. Suppose, in the Edureka front, I can tell you, we give you some course, basic stats course that is needed for you to get started in, because it's not that, if you don't know stats you can't do R, but there are a lot of, if you talk about regression, right, you talk about binomial regression, you talk about linear regression equation and all that. So it it is better if somebody comes, at least at a higher level stats background, right? Math background is enough. If you know stats, even if you don't have, there is an introductory course which is provided by Edureka, right, in case you are coming to Edureka, right? So that's there, so that uh, most of them become very comfortable in that, right? So how R is integrated? Any other tools that we learn? Pradeep, as I told you, right, R can integrate with SAS, and R can integrate with SPSS. It can integrate with any of these things, whatever you're looking for. Because even as I said, SAS Studio, right, they give an option to connect to R. Because end of the day, they don't want people to, because we are talking about ecosystem where thousands of tools will be working in unison or in tandem, right? In most of the companies, it's like asking, will I? A lot of people ask me like, will I use Pig or will I use Hive? In the big data front, right? When we talk about ecosystem, all these tools are bound to exist, right? So it will be working with uh, in tandem. Is it mainly developed for space and astrophysics applications? Giridhar is asking. Uh, Giridhar, I think I told you the example of telecom, retail, analytics in various fronts, right? R is deeply entrenched into all these domains, right? So you are going to have, it has gone into all the domains, right? Because it's very simple, it's open source and it's very powerful, embraced by a large community. So people are finding it very interesting, right? So people are really, R is gaining more and more popularity. R is used in data analytics more or business analysis. In fact, it's both, Krishna. In fact, it is, you have fantastic tools in data mining, fantastic packages that can do data mining in R. And in R, you can do regression, you can do logistic regression, you can do linear regression, you can do exploratory data analysis, you can do random trees. I mean, all these things are there in R, right? So it's very powerful that way. Can we use R within my Java application using Eclipse? Uh, Giridhar is asking this question. I've not tried this, Giridhar. Maybe it's because I know Python code can be embedded, right? I'm not sure. Can we embed Python code in R? That's a good question. Prasanna is asking. So probably possible. I've not tried this, but it should be possible. I'm not sure about the Java front, Giridhar. Can I take input directly from SQL? Yes, it can do, Ravi. Yeah, sure. Uh, Giridhar asking, can we use my Java? Yeah. So Giridhar, maybe, I don't have the, I don't want to say which I'm not too sure. So, but yeah, it's a good question. But probably, because you can do Python, so I'm guessing that, it should be possible to plug in our code as well. I'm not sure about this though. So, friends, any more questions? Maybe invoking at shell level, probably possible, Giridhar. Yeah. So, friends, thanks for being pretty patient. Yeah, I think there is one other question coming. How to find particular ML algorithm for particular real-time scenarios? Great. Okay, because there is lots and Real-time scenario, I think, because first thing is, you have lots, and you saw the varieties of ML algorithms, right? Okay, both in terms of supervised learning and unsupervised learning, right? So you need to know which one to employ where, based on the needs. For example, if it is a classification problem, right, we went about k-means, right? So business analytics, finally, I want to end it with this note, friends. Business analytics, right? It's not about just technology alone, right? Or R, for example, right? It's not about technology. It's about knowing the business domain um, pretty clearly, right? You must be clearly knowing, because domain expertise comes with lots and lots of expertise, right, in a particular domain. And business analytics, again, I want to give you this perception, I mean, this note as well. It is different from, people think that, BA means data. You understood the difference between BI and BA, okay? And BA and data science, again, you need to be aware of what is going on, right? Because BA, it's more domain oriented. People who are in rich in, people who have good knowledge in domain, they will they will come up with, um, what formula or technique they need to employ to get effective result in solving a problem. So that is your BA, right? Whereas, and of course, it comes with strong business knowledge that helps us to use which technique or formula to be used. For example, I need to know if it is K means clustering, right? I mean, of course, someone needs to know, how many clusters I need to have in a particular domain, what I'm looking at, right? So that knowledge, right? Domain knowledge is important. That is from the BA. Whereas in the data science perspective, it is more in, somebody is a data scientist, they will try to figure out how to optimize an algorithm itself, right? How do we derive, optimize? So that is a job of a data scientist. So that is something I wanted to tell you as well. Industry experience comes with, of course, it comes with experience, friends. Industry experience, based on the domain what you are into, right? Any business domain, whether you're retailing, insurance, uh, there are lots and lots of domains, telecom, and um, all these friends, right? So these are all the domains for you, and it people who have the industry experience, business analysis experience, right? So they can, employ these skills. They are wonderfully, they are going to complement your overall domain experience, and you can become a very good business analyst, right? It's going to be a very powerful role down the line. So it's absolutely guaranteed that, this role is there, and it's going to be uh, security, absolutely yes, Giridhar. Can we use this analysis? Absolutely yes. Cyber security, yes, you can do that too. Yeah. So, friends, with this note, hope you've enjoyed the session. Hope you found it useful. And thanks for extremely being patient, because I was initially not, uh, probably I might not have answered certain questions initially, because I didn't want the flow to get broken for some of the rest of the audience, right? So thanks for being supremely patient, and thanks for staying up and asking these questions. I found this to be very informative. In fact, talking to you guys, right, I learned quite a few things too. So and with this note, I want to end this session, friends. So, and please spend some time on the feedback. I would really appreciate if you can do the feedback, right? Because that's after I end the session, you're going to have a feedback coming in. Please provide your thoughts, because we'll try to see, because Edureka is what it is today because of people like you giving very valuable feedback, and we take it up very seriously, right? So thanks, friends. I'm going to end the webinar. So thanks one thanks once again.